Hi, in this video we're going to go over problem 3, which is actually calculating the size of a data warehouse. And in this particular example, we're actually going back to Lab 3.3, where we're doing ER diagram exercises and data warehouse calculation. And I'm looking specifically at problem number 3, where we're looking at Blue Ridge University. So just a little bit of background. We had completed Blue Ridge University in some of our previous exercises. And Blue Ridge University is actually in your database for this course, or in your instance of your database. And just as a quick refresher, we know that we have student grades, which is in Blue Ridge University. And we have 4 specific dimensions. We have the student, which kind of links these up. We have the professor, we have the course and section, and of course we have the time period, of course, when the student has taken a course. The 2 measures that we have is the course grade and the numeric grade for the assigned semester. So what we want to do is be able to calculate how big of data warehouse or how much storage we actually need for this particular data warehouse. And one thing to kind of take note of is you have to kind of stop and think a little bit about what it is that we want to measure. Now, I can tell you right now we want to look at specifically the fact table, but we need to understand why we want to look at the fact table. Now, consider the fact that if you're in a university, how many additional professors will be added to this particular table between, let's just for discussion's sake, between the fall and the next spring semester. Now, you're probably thinking, well, maybe 1 or 2. The answer in truth is very little. So we're just going to consider that the changes in this particular table is going to be small. Now, in addition to that, we can think about the same thing about any new courses. What I mean by new courses is new courses that would be added to the course catalog. And it's very rare that new courses kind of show up between the fall and spring semester. So also we would expect this one to be relatively small as far as changes. Now, we can then look at the period, and we're only going to be adding 1 more semester onto the period table, which will be the new spring semester. So we only have 1 semester added. And keep in mind, every time that we add something, we're only adding 1 row, right? So this is going to just be 1 row. And when we look at students, now we're talking about between the fall and spring semester, there might be a few students that drop and then a few students that return or get added, but also this is going to be relatively small. Now, it's probably going to be the largest out of all the other 3 dimensions, or the smallest of all 4, but it is still going to be relatively small. Where we see the most amount of change between semesters is going to be right here at the fact table. In fact, you would see hundreds, if not 1,000 plus new rows that would be added to this table every semester. So this is common for data warehouses. It's the fact table that we need to really store our data in. So we're going to focus more on the fact table as we kind of do this calculation. Now, in our assignment, we have some information. We know that Blue Ridge University wants to be able to record data for up to 10 years. Now, keep in mind, this is a data warehouse. It doesn't mean they get rid of the old data, except that this is how much they want to put into the data warehouse. Now, they also have some business rules. Each course is an average of 40 students, and students can take up to 5 courses per period. There's typically 200 professors at Blue Ridge University at any given time, and during any given semester, the college offers an average of 500 courses per section, or 500 course sections, so 500 courses. So there's actually 500 classes going on. Now, our first question is, estimate the number of rows in the fact table. And in order to do this, we actually have to come back and kind of think about what constitutes 1 row here in this particular table. And a row is, a student who had taken a course at a certain particular semester with a professor and what was the grade they earned. So really we want to look at how many student grades do we have. Well, one way of kind of chopping this down is to first think about what is our smallest unit of measure, and we would kind of think that you could look at, well, how many student grades might be recorded in one semester? Well, we can kind of think about this in multiple ways, and we need to look at the data that we have up here. Now, I'm going to tell you up front that some of the data that is located up in this area is actually red herrings, meaning it's there, but it really doesn't give you anything that will help you make this calculation. So just kind of keep that in mind. So when we think about, okay, well, I have one semester and how many grades are going to be recorded? Well, the first thing that I have is that is really helpful is that during the semester is that a college offers 500 course sections. So that's 500 classes. Okay, well, so now I'm going to kind of change my color here, and I will say I have 500 classes. All right. Well, now I have 500 classes. How many students are in each class? Well, also I have information here that says I have 40 students on average per class, right? So I know that in one semester with 500 classes that I'm going to have about 40 students, right? So that right there is how many grades I will record in one semester. Now, if I want to look at how many I'm going to have over 10 years, I just have to multiply that by 30, and that is because of this number right here. So I'll come over here and say that is also by 30 periods. So now if I did my math correctly, right, so I have 5 times 4, which is 20, right, and then that is 3 zeros, 20,000 times 30, right, which then becomes 600,000 records, right? So that will tell me how many records are actually going to be held inside that fact table. Now I need to double check to make sure that is correct, and that is what I have on my answer sheet right next to me. So the second part here, so 600,000 is the number of records, which is the number of rows in that fact table, right? And so we have 600,000 records that will be recorded over 10 years. Perfect. So now we want to look at what's the total size of that fact table. Well, we know that we have 600,000 records, right? And now we have to figure out, well, how much data does one record hold? Well, each field has an average of 5 bytes. So we're going to have 5 bytes of data. And we want to know how many fields that ends up becoming. Well, let me kind of show you where that information comes from. And I think I'm going to end up having to delete what we have here. So when I look right here inside of our fact table, I know that I have 1, 2, 3, 4, 5, 6 fields. So I have 6 fields, and I have 5 bytes of data, right, which ends up becoming 30 bytes per record, or per row in that fact table. Well, I already know from the previous question that I'm going to have 600,000 records, so I can easily see that is going to be 18, carry my zeros. There we go. So it's going to be 18 million bytes of data that I need to be able to store. And that becomes basically 18 megabytes. So, so that way you have an idea as to how to calculate this. We now have the total size in the fact table in terms of bytes. And really we can apply that in any kind of data warehouse calculation. Now, 18 megabytes is not a lot of data. So we know that this is a respectively small college. It could be a small community college. But of course, if we had more classes held per semester, possibly even more students per semester, we can easily see how this can grow quite a bit. All right, so I think that I hope that helps you out with this particular assignment, and we'll talk to you later.